it's a it's the way the industry is going. I just this is knowledge from other places. So lazy means that you will not send it, but hot means that you send immediately. But basically, if you do lazy, you will say, okay, I will just create a mapping and assign this money now to this person, so that the next time the person comes, the person's balance is showing this amount of money and the person can withdraw it. Or you can decide to send the money immediately to the person from the contract, right? So these are different ways of achieving this particular this thing. But remember where we started, we are trying to solve a problem. But I think changing the way you think about all these things would help to understand them better, right? Like I'm not like your reasons are valid, but I think over time, like you develop this programmer's mindset, if that's the right words to use. Like there's a way you see problems, and I know, yes, these things sound very abstract when you don't apply them a lot. That's why we have assignments, right? But I feel like with time too, when you build more things, because when you just keep consuming information and you're not using them, you tend to forget, or you tend to you just with time it just fades away if you don't use them. Yeah, there's some things you have actually seen in articles, but you forget it soon. Like you forget it soon, and you will not even a point to reach about you don't even remember that you once knew those things, right? So yeah, I think the mental model helps, and over time it will grow on you. Like you just understand all these things, right? So I hope this helps. But yeah, yeah, that's just what I have to say about what you said. But yeah, the assignments would help you to like just um not just like just thinking about the problems thoroughly. That's why I like when I see it's not like I want you to do those, but if you can't do it, like I like when I see contracts that are robust. So okay, I would come to that later. So basically, I forgot what I was saying. Oh, what was I even saying? Um,
You said you like contracts that are robust.
Thank you. So yeah, when I during that assignment when I was going through it, yeah, I saw a contract. So the word robust means that you build it in a way that you're able to optimize for different scenarios. And before you're able to come up with those kind of solutions, um, you need to have like thought about the problems well. Like if you see a problem, if you see a solution that is robust, you know that the person has thought about 1,001 scenarios, and you see that the person has done a lot of checking. You understand? So now all these things I know, yeah, when I saw that code, I could like I was 70% sure that this person is already a programmer or has pro experience. But basically, it just means that this person have developed a mindset that um you need to think about problems like the way you think about your normal problems in life. How do I solve this problem? You're thinking about if this thing happen, this is what I'll do, if this thing happen, this is what I'll do. So yeah, this is just a mindset that would really help you in seeing these things differently. I hope this helps. Messi, your hand was up. Sorry for yeah, your hand was up. Please go ahead.
Good evening. So
Yeah,
my
good evening.
problem, my the expense will actually be okay and a little bit challenging, and I also have almost the same this thing with Elizabeth, but I've also listen to what you have to say. And another issue for me is that the fact that I was coming from a data science background, so and I think I started this Web3 this thing around May. I learned JavaScript first. I started with JavaScript because I already have a little background of HTML and all. So sometimes when I'm just like coding or trying to learn, I feel like I'm I'm at a disadvantage compared to people that were already software engineers, like front end or back end. That if we are compared to each other, them they might like have more advantage. I mean, that thought actually like brings me back down. So I don't know if there are some smart contract developers that they weren't front end engineer before or back end engineer, like they just switch from maybe UI UX or any other this thing and come straight to smart contracts or Web3 or blockchain developer.
All right. Yeah, that really makes a lot of sense. So Um, Definitely, someone who has pre-experience of programming is is definitely has more advantage, right? But I think it's like that in life basically. When you're doing some things, right? When you're doing some things, there's some people that have even in class, right? You see some people that already know more than this person knows, you understand? But that just goes to tell you that our paths are different, our journey, everything is different. So I think this is a personal journey, right? In as much as this is a class and stuff like that, the goal is I want to learn solidity, right? The fact that it takes my colleague 3 months and it's taking me 7 months doesn't change the fact that I would learn solidity, right? So yeah, this person already has knowledge of programming, already knows how to write JavaScript and stuff like that. But to be honest, that doesn't change the fact that you are on a personal journey to learn solidity or to learn blockchain, right? So basically, yes, that doesn't really like yes, relatively compared to the person you're talking about or the people you're talking about, yes, if you guys should be put on a scale, they probably learn it faster than you, but in the grand scheme of things, what matters is that do you know solidity? And when you finally learn, nobody will ask you what you knew before you started learning it. Everyone will just like now you know solidity, or now you know how to write blockchain applications, or you know how to build blockchain applications. So basically, the comparison, or if you're doing a hackathon, right, you can say, yeah, I'll get to you. I'll get to you. So if you're doing a hackathon now and you're like, yes, you might start doing the thing in your head. Okay, these people are more influenced. I mean, blah blah blah. But to be honest, at the end, the goal is to learn solidity or to learn blockchain. And if you're on that journey, when you finally know how to do these things, to be honest, what will now matter is that you now know how to do it. Not really at what point did you start learning or whether you were doing, in fact, you were doing like data science. There's people that just wake up tomorrow from a non-tech field and say they want to learn how to code and they now start learning solidity, which normally they'll advise them to go and learn JavaScript and stuff like that. But some of them find their way and they start writing solidity and they are solidity developers today. Do you understand? So basically, I understand you totally. I'm not trying to say it's not. Yeah, so I'm not trying to say it's not valid, but just know that you're on a personal journey to do these things and everybody's experiences are different. Everybody's experiences are different, and everybody's on their own journey to do these things. Even some people now, you might like she just said now, I'm a front end developer and everything. So basically, even as a front end developer, depending on where you are, all these things might still sound new to you. And that still goes back to the point. We are on this personal journey to do these things ourselves, right? To learn these things, right? So basically, to me, it doesn't really matter where another person is at on their own journey. Basically, I want to learn this thing, and based on all the factors surrounding me, all the factors around me, I will do what it takes to get to where I want to get to. Do you get? So basically, the reality is that this is where you're coming from, and this is what you this is your knowledge gap. The problem now is how do I try to solve, how do I to close this knowledge gap, and how do I try to reach an extent whereby I'll be able to learn this thing easier. So that's the point. That's the goal. Anybody that knows how to do, in fact, there's some people probably on this call or that joined this session. Like I remember when I joined one program like that, and I was so sure that was like 1000% above like what the whole thing was all about, right? But that didn't really matter. Everybody came in there to learn their own thing, right? So there are some people that are more like they are probably been coding very well in another language and they are here trying to learn Solidity, and they'll learn it very fast. But that doesn't really change anything. You're on your own personal journey to learn Solidity and to learn blockchain. Understand? So these things are personal. Doesn't really matter what another person knows. Relatively, yes, they might be above you, but in the grand scheme of things, those things don't really matter. The goal is to learn Solidity, and when you learn Solidity, the only thing that people want to know is that you know how to write Solidity, not that you knew this or you did not know that. So yeah, I hope that helps. Okay, Chi, go ahead.
Thank you. It's just while she was the last speaker, while she was talking, I was actually laughing because okay, let me I just sort of want to encourage her because yes, she even has previous experience in data analysis. I joined this track with zero coding knowledge. I this solidity class. I did not know anything about coding before coming in, and so I've I've been struggling. But what has been my saving grace is the fact that I've been an active crypto trader for over 2 years now. So I was already very familiar with most of the terms you guys are talking about. I'm very big on airdrops and test nets. I've been following blockchain networks and how they work. So that has actually been the only thing that has been keeping me here, because I had zero coding knowledge. And as my own way of trying to make up for it, I'm taking front end classes alongside this one. I registered in another class for HTML, CSS, and JavaScript, and that has been going well. So, to that last speaker, I just want to tell her that she's not alone. Me, I'm totally new in all this. Coding is totally new for me, and I know that, of course, there are people here that have been programming before and they have uh, an edge over me. But what matters is that we all get there. If it will take them 3 months and take me, like you said, 7 months, I don't mind. What matters is that at the end, we all end up as developers, blockchain or
Yeah.
solidity developers.
Yeah. Thank you very much for that. Thank you very much. I hope this helps. Yeah. Rita. So, yeah, I think I sent you a message earlier, but I don't know if you saw it. But yeah, it's already evening. Maybe we can do the call tomorrow, because I don't know if I'll be free today again. But yeah, we might do the call tomorrow. Just yeah. So I've heard all you guys said, and to be honest, my sole purpose, my sole goal is that you learn blockchain technology and you learn Solidity and you know how to write code and stuff like that. That's my goal. You understand? Like the umbrella that's helping me to drive my goal is Web3 ladies, and I'm a mentor here. But my goal is that you should learn Solidity. You should learn how to code in Solidity. And I know it doesn't end here. Like even if after the bounty, what to change, sorry, what to help you know these things very well is if you don't stop, right? So when I see the former, like the alumni of this Web3 ladies, what I ask them is that, like, are you still doing this thing, right? Because I know even if we spend 8 weeks here, like, is that bad? If we spend 8 weeks here and from the beginning we start coding Solidity up to now, if after the 8 weeks you don't touch it again or you just leave it, I give you 2 months to forget everything you've learned. Not like literally forget, but you find out that you suffer in knowledge if you try to start again or if you try to do it again. So what really matters is that you've joined this program that would help you on this journey, and you would take it very seriously. Like I said, a personal journey. Right? All these things are personal. Like all these things are personal. You trying to learn Solidity is your own personal goal. You register this thing yourself, say you want to learn it. I know, yes, we're dealing with other people, and like sometimes other people come and answer questions. It seems like they know more stuff like that. All those things, to be honest, in the grand scheme of things, it doesn't really matter. Everybody's running their own race. You understand? Everybody running their own race. You understand? So yeah, always just have that. Why I always say go back and learn these things, right? If you have issues, send me a message. I'm not telling you that I'll reply you in the speed of light, but I'll definitely reply you when I find the time and probably have a call with you. You understand? So yeah, just that's just what I want to say. I've heard a lot of what you guys said, and on my own part, probably I don't know if I was assuming you guys like okay, though I didn't really assume that you guys had. I just was just trying to explain as much as I can, but now I know that a lot of people don't really have prior experience. I'll see if I can even talk about basic things better. But yeah, thank you very much for airing your views. And if you were not able to speak here, you can send me a message. Like I asked the first time, if you have any particular topic that you would want us to talk about again. I think next week is week 7, and it's a free week for review and stuff like that. So you can send me a message about the topics you want me to talk about. Then on that Monday and Tuesday next week, we'll talk about those things all over again and try to explain them as much as we can. So if there's any topic you're struggling with, just send me a message and I'll take that down so that I can talk about them in the next week. So yeah, thank you very much. So let's start today's class. So yesterday, I think it's Elizabeth Ogechi, but someone told me that let's deploy with Hard Hat and Foundry. Yeah, so we'll start with that. So this is how today's class is going to go. We'll deploy a contract. The contract we did yesterday, we'll deploy it with hard hats. We'll also deploy with Foundry. Then I already have a code, like some code I prepared before the class to be able to explain Ethers.js and Web3.js. So if we finish these and we still have time, I'll go through Mercury. But the thing about Mercury is that it's confusing. I might not understand it, but I'll try to explain it, right? I just want to prepare your mind. The high level explanation sounds it's kind of intuitive, but when you come to the code and the whole logic of trying to achieve that particular Mercury functionality, it's a bit complex. But yeah, that one I want to talk about it last because if I start talking about it now, I'll probably get confused too. So talk about it later at the end. So yeah, let me share my screen. Can you see my screen, right?
Yes.
All right. So today I'm using only one screen. There's no light. So I would I'll just be going between screens, so just bear with me. So now, first of all, we'll try to achieve, and also I'm not on the same screen, like I said, I'm not on the same screen. So if you send a message, I might not see it. So if you want to say something, just unmute yourself and speak, because yeah, so I can be able to see it or hear you rather. So yeah, is my screen clear enough or should I zoom in?
Please zoom
Please
in.
zoom in.
All right. Okay. Okay, I think you just need to see the terminal because we already talked about the contract yesterday. So it's just the terminal you need. So can you see the terminal? So yeah, we're in our folder, we're in the hard hat folder. So let me go to the hard hat documentation and find out how they say we should compile, right? Sorry, we should deploy. So let's go to documentation. Let's go to documentation and see. So deploying. So let's see. Okay. So yeah, the way deployment works in hard hats is that you write a script. You know, the last time I talked about the script. So it's inside of your script that you would specify all you want to do, right? All you want to be able to like apart from the normal testing, which is in the test folder, in the script folder, you have things that concern things that concern deployment. So let's see what's there right now. So in the script folder, we have one script, which is the deploy script. So yeah. So I think because of our contract is very simple, it won't take us much. So these things are not really necessary. So let me just remove a lot of these things so they don't look. So let me remove most of this. So this is not necessary because it's for the old contract, right? It's for the old contract. So I think all we need is this, just this two. Change, let's see the name. I think we gave it name, or did we change it? Or is this, let me see if it's test. Okay, it's test. So name of the contract is test. So we just change this to test. We change this to test. This is test. Test. So what is happening here is that what's happening here is that this particular line of code. Okay, my second screen is back. Let me. Yeah. Sorry. Yes. Give me a minute. I'm trying to set up this. I don't know. I'm really hard to. Can you guys hear me?
Yes,
Yes.
sir, I can.
All right. Sorry. Just give me a minute. I'm trying finding it hard to. Let me join again. Yeah, yeah. Okay. Sorry about that. Mm, Having issue with my screens. Yeah. Let me share again. Hmm. So yeah, this is better. So yeah, um, back to what I was saying. So this particular line, which is this line, it gets the contract itself. So it gets the undeployed contract, right? It gets the undeployed contract. So this is what this particular line is doing. So I gave it the name test. Then this next line actually deploys the contract. You understand? It deploys the contract. So assuming this contract required any argument, it will be here, right? It will be here. But this contract doesn't. So I just use this, right? I just use this. So then, okay, I'll do that. So yeah, so this particular line gets like waits for the deployment. So this line here deploys it, but because of deployment is not an instance process, right? So this like tries to get the deployed contract, which might not be instance or which is not instant actually. So that's why we have to wait for that. Then this is just a random line of code that we can remove. Well, let's just write deployed here. Let's just say deployed.
Your screen has frozen. Oh.
Okay. All right, give me a minute. Yeah, it should be back now. Yeah, so yeah, I'll now say deployed. Yeah. So this is our deployment script, right? This is our deployment script. Then now let's go back to their documentation and see what they say we should do. So basically, you can return a couple of things from what you have deployed. So we can come here now and say want to return the address. So want to say, okay, let's just say console log contract address. Then we can just add in the test dot address. All right, so let's just do this so we can be able to see the contract when we deploy it. So think so yeah, so there are some configurations we need to do in our hard.config before you are able to deploy to a test like a test net, a live network. So let's just do this quickly. So in the hard.config, let me add a couple of things. So first, I need to add networks. So Goeli. Okay, the only network that survives the merge. They just gave us only Goeli after the merge. So unfair. Okay, Bakari, go ahead.
Okay, sorry, this network you're specifying is for what?
So I want to specify the network so that when I deploy it, I can just point to the network.
Okay, so are we
So
deploying on this network?
like whether I want you to do it or I want to do it. Yes, I want to deploy to the network. I want to deploy to Goeli
Okay.
testnet.
Oh, okay, okay.
Yeah. So yeah, yeah, go ahead, Ogechi.
Sorry, I just wanted to ask. The merge, was it the reason why Robson and Rinkby stopped working?
Mm, I won't really say stop working. They just deprecated it. They stopped using it. It's not like they stopped it by themselves. Not like they stopped working. You get?
Yeah, yeah.
All right. So yeah, I need to add our RPC URLs. So now let me explain this concept because
Please,
this
can
is
you
a
repeat
very
what you said about the network?
yeah. I said um is it what Ogechi asked?
No, I was one asking.
No,
My
tell me.
network went off, so I didn't hear what you said about the networks.
Okay, I just said that they didn't really like it didn't just stop working, but rather they deprecated it because I don't know why, but they just deprecated it, meaning they stopped using it, just stopped functioning. So they just stopped it basically.
No, I was
So
talking about the
this now,
question of Bakari when she said, "What are the networks for?" As in, what are you
oh
using the
oh
network for?
okay, yeah. So because of like I said, this hard hat of config is more like the just like the settings of hard hat in your folder. So basically what it does is that it contains all the whole settings, the configurations. So I want to be able to specify network. Then when I want to deploy, you see where I'll add in Goeli as the network I want to deploy. And when I do that, to come here and use what I defined here, like these things I'm adding here now. These things I'm adding here, it will use them while I'm deploying. Now, I want to say something. Like this URL I just put in now is called an RPC URL. And the idea behind this is interesting and it's very, very important to understand how the blockchain works. Now, I didn't treat the basics of blockchain with you guys, but one thing that we all know, maybe, which they must have talked about, is that the blockchain is decentralized, right? And it is a peer-to-peer network, right? And each pair is interacting with another pair. So there is no one user that is the like master of all, just like the way servers work. So a server now is you just have one server and everybody's interacting with that server. So you ask the server something, the server gives you a request, you send again, it sends you a response, you send another request, sends you a response. That's how traditional network work, which is client server model, right? When a peer-to-peer network, you have individuals that own their own server and they are running it independent of another person. You understand? They're running in as much as they need each other, but it doesn't really mean that they can't that one person is higher than another person. It just means that everybody needs to work together for the network to work collectively. Now you might argue about that because there's some network that like proof of sorry that like Binance matching now they do this thing whereby they have just a set of people that are doing the whole peer-to-peer thing. But yeah, the blockchain is the blockchain. This is the ideal. What I'm explaining is the ideal way blockchain is meant to work, right? So people might argue that yeah, this is why they're doing this is why they're not doing it. But based on how Ethereum is working right now, everybody you can run your own node and you can even validate transaction. Okay, you need to be a validator. That one is different. But if you want to get the live data from the Ethereum blockchain, you can run your own server on AWS or even on your yeah. So even on your personal computer, you can run your own Ethereum blockchain, you understand, and you can interact with other peers. But now running a node is expensive. Like I tried this I think I tried this a while ago. I think I tried it last month and I started an AWS server and in less than 2 weeks in less than 2 weeks my bill was already more than $100 and they've not even started like they've not finished charging me like it was just going like so for someone if you say okay yes you want to do it for the good of the network but you don't have any means of income then why would you do such a thing so it's not really like sustainable for someone that doesn't really have a lot of money to spend because even if you're earning salary and you are spending $300 every month for something that you're not getting anything then then I don't think that's a good investment in as much as you're doing it for the community stuff like that but for it to be sustainable, somehow you need to have surplus, or yeah, you just need to have surplus. So what I'm trying to say in essence is there are ways to now talk to the network without having your own node. That is where this thing comes in. Now, these guys, they run multiple nodes and they charge you a fee to use their own node. So that's why you see gueli.infura.io. Infura is the service provider. And this thing here is my own key, like my own, just like API key, if you call, like just like they're offering me an API and this is the key. So this is the key that they gave me. So actually, this is actually secret. Let me try to pick the Gueli URL from. Oh, no. I actually have it somewhere else in my browser and I just went there to copy it. Like you can go to infura.com and you can get your own there, but I'm already using this. I actually use this for what I was talking about later, which is Web3 JS and it has a JS, but I just copied that and brought it here. But if you want to get yours, you can go to infura.io and register and you can get a free URL, but it has a limit now. You understand? But it's I'm not even sure you'll be able to consume your limit. It's actually a lot. So you might not be, if so far you're just using it to test, you will not consume all your stuff. So yeah, so basically my point is these guys, they offer nodes so that you don't have to run yours. And even if you want to scale and say, okay, you want to start running a lot of transactions in a day with their URL, the amount of money you will pay is way lesser than how much you pay if you're running your own node. And now, mind you, running a node is not just all about hosting it. It's about maintenance. You need to be maintaining it because you might find out that your node is not syncing properly. What do I mean? Like, because this thing is a peer-to-peer network, right? And everybody's communicating with each other. So if I add a transaction to the blockchain using my own node, the node beside me or the node closest to me has to communicate with me so that I can get that transaction so that everybody will be on the same page, right? So all these things might stop. Like that's why I said syncing. You might not sync properly. The syncing process happens automatically, but in a situation whereby you don't sync properly, you need to have you need a DevOps engineer to go and look at it and say, okay, this is why it's not syncing properly, or you need to write automation scripts that will be doing something for you on the node. So this is why running your own node is expensive, right? So we use these services so that we don't have to run ours ourselves. You understand? So it's actually good. But yes, you have the cons, which is it is now as I'm using their own, it now looks centralized because now I'm depending on them. And anything they like, they are doing. I don't even know what they're doing their server, but yeah, there are pros and cons in everything we do. So, but right now, there's nothing there. I don't see anything there. So probably if you run a very big application, then you now have to start thinking about running your own node and hiring your own engineers to manage your nodes. But at this point, this is okay. So my point is this is an RPC URL, and the RPC there stands for remote procedural call, which you don't really have to bother about now. So just see it as an API URL that we send calls to and gives us a response. So the next value that we need to pass in here is the private key, right? I know you must have heard of private keys, which is just like your password, but this one is very, very secret because this private key I'm about to put here now, if I have money in it and you go and check it, you can collect my money, but I don't have money in it. But if you want to see whether I have money in it, you can go and check it yourself. You okay? Yeah, but yeah, I'll just paste it there. I'll paste it there, and yeah, but yeah, it's actually empty unless you need testnet tokens. You can go and use it. But yeah, so I'll come here and add this accounts, and I'll add. Okay, it's already late. I would have just done it using EMVs, but I don't want to start going. Don't worry, you can see my keys. It's fine. I don't actually use this, so yes, you can use it. Yeah. So now we have these two values, right? And this will enable us to deploy on Goeli testnet. Because first of all, we need a URL to communicate to the blockchain, and we have that here. And we also need a private key because you need to sign the transaction, and we have that here. So these are the two things we need. Now, if once I have this now, what I'll do is, let me check the doc. Let me check the doc. So I'll just do npx. So the normal npx we're using is hard hat. So deploy.js. Then we specify the network. So now you see why I added this here, right? Because now, so that I can pass in this here, and when I do this network tag, it just comes here and look for this. So it's just using this name and it just comes here. I can, in fact, I can just use another name that is not Goeli, but it will be confusing if you really don't know how it's working. So if I come here and use another name, it will still work. So far I put it here, but because we know that there are only a few networks existing, so if you put something else here, it will be confusing for the person reading your code. So this is Goeli. So hopefully this should work. So what this is meant to do is that it is meant to run this script, right? It is meant to run this script, and this is this one we wrote here, right? So when it runs the script, then it will now do everything. It should do this. It should do this for us. So let's try that and pray it works. So let's see. So fingers crossed. Okay, I think it's working because it's taking a bit of time. So yeah, it's communicating to the network. So just like making calls, API calls, it's not really instant. So we just have to wait a bit for it to work.
Good evening. I
Good
wanted to
evening.
ask if you don't have the goalie token, because I remember the very first assignment we had, I actually wanted to deploy using this goalie testnet, and after setting up everything in the that config, it didn't go because I did not have the token. So I wanted to, is there a way you can actually deploy to the testnet if you don't have the goalie token itself in your MetaMask or something? I don't know.
All right. So that's a very good question because I have test tokens on this particular private key. Like not really on the private key because the private key maps to an address. So I have token on the address. So that's why I'm able to do this. But if it's not enough, they'll show me an error now. But it's actually I have like I have a couple, and I think it will be enough for me to deploy this. Is this thing even working? Like why is it not showing anything? But yeah, does that answer your question? I don't know if this is. Like, let me run it again. I think it's taking a long time. Yeah, there are faucets like that. So I used paradigm faucet. So just write paradigm faucet, and the first link that comes up is a paradigm. I don't know if you know paradigm, but they're really big. Yeah. So they have this faucet that have been saving lives for months now. So you can just go and use it. They will allow they'll just when you put your address, they can send testnet token to all network at the same time. So this is taking long. I don't know why. Why is this taking a very long time now? Oh. So it's actually working because I noticed that they've deducted my money on MetaMask twice. But I don't know why it's taking a long time to show here. I think is because of this particular line of code, which is that it's waiting for the transaction to finish because they've deducted twice, meaning that it has been charged, but it did not reflect. So wait, let me go and check the address and see the transactions that happen on the address. Yeah, okay, thank you for that. So it actually worked, but I don't know why it's not printing anything here. It's supposed to print something out here. I think this is what is taking time. It's waiting. Mm. So while we wait for it to finish, let me say something. So since yesterday, if you see the pattern I'm using, right? I want to do something, I go and check the documentation on how to do it, right? Because there are a lot of tools, and there is no way you know how to use everything. For instance, now, if I use hard hat for the next 2 weeks, I'll cram their code like these things, right? Like there was a time I used to use hard hat every day, and I knew all these things off head. But once you stop using it, it will leave, right? You just like you you can't possibly cram every single like command in your head. So basically, what I'm saying is always 99% of tools have documentations that you can use. So once you just want to use any tool, go to their documentation, read their setup guide. Sorry, read their setup guide. That would actually guide you on how to use it. So I don't know why this thing is not. I think this is taking a long time. But let me stop sharing this particular screen and share and show you the contract that was created because it has actually worked. So let me show you something. A window with tab, brother. Yeah. So let me go back. So if you see this 2 minutes ago, right? And this is the address. Because like I said, a private key is secret, but a public key can be public. It's from the name, it's public, right? It can be shared and nothing will happen. But for you to get an address, so it's just like a one-way for something. A private key generates a public key, then the public key generates an address. So for every private key, it has a public key and an address that it can sign. That's why I didn't show my address anywhere, but my address is showing here because the blockchain doesn't like basically when you send transactions to the blockchain, you're kind of passing a signature. And when it goes into the blockchain and it's been decoded, they can get the address that the private key is tied to. You understand? So your private key should not be stored. But once you sign, that's why it's called signing of transaction. Once you sign, your signature will be there. Then when they go to the blockchain, they will be able to decipher who did it. When they get the message, once they get the message that was signed and get the signature, they will be able to get the address. They will not be able to get the private key, but they'll be able to get the address. That's why my address is showing here. So this is the contract that was created. Wait, let me refresh this. Let me refresh this. So 6 minutes ago, right? So this is what we just did now, but I don't know why that one didn't show. I think because of the await command. So this is the contract. This is the contract. Look at it here. So these were the ones I did before, but yeah, this is it. 6 minutes ago, the operation I performed was contract creation. So this is a new contract, but I've not verified, so I can't possibly, because for me to be able to see it here. Okay, wait. Let me actually try to verify it. Let me see if it will work, because this takes a while sometimes. Let me see if it will work. 0.7 compiler type single file. I think this should work. Let's just use this. Use no license. Continue. So basically, I want the functions to be shown the way it's to show in Remix. So that what I'm doing. I'm trying to verify. So I just want to show you guys that it has actually worked. Thank God it worked. So let's go back to the address. Now we can see the operations. Okay, go ahead. Go ahead, ask.
Please, are you sharing your screen or is my network? Because I can't see anything.
I'm sharing a screen, boys, on Etascan, not my Visual Studio Code. But yeah, I'm sharing my screen.
I can't see anything at all. Is it just me?
Can any
It's
other
your
person?
network. It's your
Okay.
network. I can see it's a scan here.
Oh, all right. Thanks.
So yeah, so basically I've verified and now it's showing here, right? So if I come to read contract, I can see the operations, the read operations. So if you come here now, you see name. So once I press name, it's showing gospel easy. And if I do write, okay. So this one on Visual Studio Code has finally shown. So I'll go back and show you guys. So then if I do write, then I can update name. Let me change the name to Mr. So once I do this and I do right, okay, sorry, I need to connect my MetaMask first. So my MetaMask has been connected. So sorry, let me see. Sorry. So yeah, once I do this, it should pop up my MetaMask and I'll say yes. And it will take a while. Let me just give it a while, then it will update. Give it a while. Let's wait a bit. Okay, well, let me view the transaction. Okay, it's still okay, so it's successful now. So if I come here and do name again, it should work now. So if I come here and do name, it should update because this one has already updated. Wait, let me see. So this already worked. I don't know why it's not instant. Let me see. So basically, I updated the name. So initially the name was Gospel Easy. So I want to update the name. So I want to update the name. So to make summarize it, so The first transaction has gone. I don't know why this is not actually updating. This thing has a lot of, but yeah, basically I want to change the name from what it was, and I sent the first transaction. I don't know why it's not updating on Remix. Okay, let me try and refresh. Sorry, not Remix. It has scan. It has changed. So see, this one has changed now. So it has changed to Mesomize. So I changed the name using that why I verified it, because if I didn't verify, I won't be able to get this thing that's giving us now. So that's by the way. Let me go back to my Visual Studio Code and show you guys. Because that one has finished, that's shown. A window. I know this is very crappy right now. I'll fix that now. I guys see this. Is this clear?
Yes.
All right. So you see this part now. It has shown this deployed, and it has shown the contract address. I don't know why it took that long, but yeah, that's showing now. So yeah, so we've been able to deploy, and we verified that it works. You understand? So I would not be doing Foundry because I just wanted to go to documentation and do it yourself. So that'll probably be among the part of the assignment. But yeah, it's not hard. You see, I don't have it in my head. I just went to documentation. What do you say I should do? I'll put it there. Replace what I need to replace, right? And another thing, we're already running out of time, so I won't do Foundry. So what you just need to do is to go to Foundry's documentation. I sent it yesterday, but if you don't have it, I will send it again if you need it. Or should I send? Okay, let me go look for the Foundry documentation again. Let me look for the documentation again. Foundry. Okay. So just take this and send it again. So yeah, try and deploy it yourself. It's not even an assignment. Try and deploy it yourself. Just do it after the call. I noticed something yesterday. I said that after the call, or at the end of the call, I said that I pushed the code. And actually, it was a mistake. I didn't push the code. But nobody noticed that I didn't push the code because nobody actually checked it. It's this point that someone was telling me that they did not see the code. So nobody actually checked the repo to go through what we did. As me, you went through the repo, you know that I did not push it, but nobody noticed that because I just committed and I thought I pushed and I said I've pushed, but unfortunately I didn't, but nobody noticed because nobody checked it. All right. So let me go through. Now I want to talk about Web3.js and Itazo.js. Let me share again. Yeah. So this is where I got the URL from. So I just came here to copy it that time and I brought it to. I just came here to copy it. Yeah. So now I want to. I don't know. Someone asked that. I think like 2 classes ago, 3 classes ago, the person asked. I think it was Bakar that how do we interact with these smart contracts, right? Because it's not just writing backend code and leaving it there. It's just like you writing Node.js and expecting it somehow to magically connect to the front end of the site. you need to make it connect. You need to put tools that make it to connect, right? Because for you to use a smart contract, you need to be tech savvy. No, not really even a bit. You need to be tech savvy to be able to um to be able to use these tools. So the reason why you have like a Uniswap front end is because of Uniswap doesn't just want only techies to be using the application. They want normal users, right? People that just want to swap token that doesn't really nothing concern them with blockchain. They just want to swap their small ether and guys and it's nobody wants not tell you that they want to they don't tell you that they want to understand blockchain. They just want to convert their shitcoin that have done 2x. They don't use and go and buy something. So yeah, basically the front end is so that you don't have to be tech savvy to use it, because there are some people that interact with this application without using these tools. Sorry, without using the front end, they just go using code, just like we are doing now, like this one now. Because what the reason why this is important is that even if you want to interact with the front end, this is what you use, right? So now let me explain this. Now there are two main tools, and I prefer Ital.js because their documentation is superb. Web3.js, I don't know why they complicate things unnecessarily, but yeah, Ital.js is like my best. In as much as I've used Web3.js more, but the more I use Ital.js, I just like it more than Ital.js. Sorry, more than Web3.js. Ital.js is better for me, but when you start using it, you know which one is better for you. So yeah, let me explain this code. So here is the import statement. So I'm instead of import, because it's in ES6 they brought about using import this from this, but normally this is how they import in JavaScript. But I was trying to use that particular syntax, which is this import this from this, import headers from headers, but this threw a particular error, so I just stopped using it. So in case you see this somewhere else, this actually still works. But if this was a node application, this will work. But this is a browser. This is just a playground for testing code. So that's why this might not work. Because when I did it, they showed me one particular error like that. So yeah. So this line basically just brings in Ital.js. Now, there are a couple of things we need to have before we start all this process. And again, all these things are in documentation. You can go to documentation and see, because it's just this morning this afternoon I did 2 of them. I just went documentation, went through it. How do I do it? How do I do it? I did it. It's not hard, right? So it's not easy, but it's not hard. Let me not make it seem like nothing. So this is the URL, the RPC URL I talked about, the same I used before, right? Then this is that API I've been preaching about from the beginning, since the beginning of this class, for weeks now, 2 weeks or 3 weeks. Now this API, let me explain. Now Solidity, JavaScript does not understand Solidity, and Solidity does not understand JavaScript. They are two different things entirely. They don't even know themselves, and they don't want to know themselves. Now, what this API does for us is that it tells JavaScript the functions that are available. You understand? So if you are trying to call it, like, see this now, let me just go through it a bit. So see this function now, update name. You see that this particular function is inside of the contract. So because of we have it here now, if you do update name, then it can know exactly what this is, right? It knows that this is a this is the name. It knows that this is the function, the input. It knows that it takes in name as input, right? So this is just a JSON stuff, right? This is just JSON. So basically, it's kind of defining every single thing. So you see this, the first one, the constructor. This is only called once, so it's not like we can call it. Once you deploy the contract, you can't call this again. But yeah, this is the first one. And I have the second one, which is update name. Understand? The name is update name. Output, it doesn't return anything. State mutability. So non-payable is not a payable function now. So it has non-payable. So here is a function. Then the input, which is the argument, it has one, which is string like it takes in name now. So when we pass in a name, it updates it, right? So this is the first function. So the other one is the name variable, right? So it doesn't take any input. The name is name. Output, it returns the name, right? So the output is that it returns the name, just like we have been saying since yesterday. Once I add my name, if I call name, it returns the name. If I use update name, it changes the name to the new name I put in. So the state mutability is view because it doesn't change the state, right? It doesn't change the state of the contract. It just returns a value and is a function. So this is the ABI. It's telling JavaScript the functions that are available so that when I call it, I'll be able to use it, right? So we can actually remove this because it's not doing anything here. So, but let me just leave it. So this is the ABI, right? So first of all, we have the RPC, what we use to connect to the network. We have the ABI, what we use to know the functions to call. Then we have the contract address, which basically tells us the particular contract that we are interacting with, right? So this one now, if you see, this is already Goeli. So like you might ask, okay, if we have the contract address, how we ethers.js know the network we're interacting with? This is why, this is how. You see, Goeli already knows, see, Goeli is already there. So we already know, ethers.js will know the network that we are interacting with because of this URL. This URL knows where it's going to, so it doesn't need extra information. So this contract address, mind you, this is the contract I deployed before. This is not the one I just deployed because I'm using this to test. So just in case you're asking, this is a new contract. This is a contract I've deployed since, and I've been using it to test since. So now this is the private key, the same I used before. Now let's come to some things that are native to ethers.js. So these things are general blockchain stuff, right? But these things are this thing is kind of it's not really native to ethers.js, but ethers.js use it like very well. Okay, ask, go ahead.
My question is that what is the ether.js used for?
It is used to interact with your smart contracts that's been deployed. Or you can also use it to deploy smart contracts if you want to.
But okay, that's if we don't want to use hard hat.
Yeah, even inside of hard hats, you can actually in fact, hard hat is a tool, right? And it has a lot of tools running inside of it. So inside of hard hat, there's ethers.js there, but they've abstracted all those things for you. You don't need to know that there's ethers.js inside of it. But yeah, hard hat uses ethers.js like very well. So yeah, hard hat abstract a lot of things for you. You understand? But all these things are there. Yeah. Okay, so go ahead.
Is there any use case for Ethers.js in when trying to connect the smart contract to the front end environment?
Yes, yes. So if you've done like front-end engineering before, you will notice that there's this like for instance now you can do on click. So if you are doing DOM manipulation, you can do on click, right? And you can set a button that say on once you click, let it come and run one of these things. You can run you can try to get the balance, your balance, you can try to get the block number, you can try to do a lot of things. So yeah, if you're doing JavaScript and you're doing DOM manipulate, like you're trying to get blockchain data, once you click on your button, you see the same ether.js or web3.js that you use to return the data to the front end. Understand? So yeah, it's very important. It's like it's in fact without it, you just have a front end. Because the same way JavaScript cannot talk to Solidity, the front end, which is HTML or React, cannot still talk to Solidity. So you need all these tools, and they're all JavaScript tools. And also, mind you can do this in Python too, and other languages. This is just JavaScript way of talking to Solidity. There are other ones. There's Web3.py. There's Web3.java or is it Web3j, something like that. But I know that there's one for Java. There are other languages you can do the same thing. It's just like making API calls. Understand? But there are tools that allows you to make them easier or easily rather. So just these things are not unique to JavaScript. You can do the same thing with other languages. Like personally, I use Web3.js. Sorry, Web3.py for Python. and I use that a lot. So yeah, there's even others called, like there's one called Brownie for Python too, for interacting with smart contract. But the idea is these tools are for interacting with the blockchain and nothing more, nothing less. Interacting with the blockchain and like manipulating the blockchain. So yeah, let's go back to our screen. So yeah, we have the provider, which is basically this. So we actually have the URL, right? But we want to like use it to create something that haters yet can use. So with this URL, like just if you just bring the URL, to be honest, it's actually nothing to it as a JS. But when you now use the URL to create something, then it now means something. That's why we call it a provider. Thinking about what I said now, this name provider should make sense because they are providing a node for us, right? They are providing a way for us to interact with the blockchain. So it's only fair that you call them the provider, right? So this is the provider, right? So when I pass in the URL here, so based on all these commands, the editors or providers of JSON RPC provider, then it creates something that we can use. And there are a couple of functions that are tied to it, right? So yeah, so before I come and interact with the contract, I want to just interact with it in different ways. So you see that it can perform many things. So first of all, I want to get the block number. I don't know if you've heard of block number. So, but there are blocks. You know, we have blocks and they have numbers. So first of all, I want to get the block number. So when I run that code, you should see the block number. So let me do run. Yeah, I don't know if this is clear enough. Yeah, but you can see 7797971. So you can actually go to Etherscan and confirm this, and you find out that on Goeli right now, the highest block right now is this 77979, or you might see that it's like one or two above this. But basically, at the time when I ran this code, this is the block number of the Goeli testnet. This is the last block. So it's for interaction basically. It mustn't really be a contract interaction. I'm interacting with the blockchain generally. There are a lot of commands I can do here. I just brought in the main ones. So let me try another command. Let me comment this out so that you can be able to see it properly. So this particular command now is for getting the balance. So this address now is the address tied to this private key. Is the address right tied to this private key. So I want to get the balance. But let me explain this code. You know that when I run this code, right, it returns the balance, but it returns it in way which is not really easy for us to understand. Like it is like I want it to be in Ether's denomination because that's what is showing in my in my MetaMask, not in way. So when I get this, okay, wait, let me comment this out and run it. So you see what I'm saying. So when I comment this out and run this, I get this very big number. So it's a big number, this. You understand? So this is dealing with big number. So it returns big number, hex, this. This is a number, but it's a big number. So JavaScript has issue with big number. So it's showing it as a big number. But this particular, this line now, this line converts it to Ether denomination. So it formats this value and returns it at Ether. So when I run this now, you'll notice that it is now showing me in a way I understand. So it's showing me that I have 0.0518, blah, blah, blah. So this is better. Like I can understand this, right? So basically, the balance of this address is this, right? And I'm interacting with the blockchain this way, right? So I can see the balance. This is the balance of the address that I'm interacting with. So we have that out of the way. So we have gotten the balance, we have gotten the block number. Now, let's go to interacting, performing operations on the contract. Okay, go ahead.
Which editor is this? An online editor that you're
Yeah,
using?
it's called Replit. It's an online editor.
Okay, Replit.
Yes, it's called Replit.
Oh, okay. Replit. I didn't know. Oh, so it can run.
I didn't
Okay,
know they
this
had
is
a
JS,
Dakar
not
version
Soul.
of that interface.
Yeah, I think you can run many languages on Replit. It has other languages you can run. A lot actually.
Yeah, I think it's just like code pen. I've used it before.
Yeah, it's similar to CodePen, but this one allows more languages. I think CodePen is mostly for front end, I think. But this one you can write a lot of languages here. Python, you can write a lot of things here. So yeah, this is Replit. So now we've done the whole, I just wanted to show you basic interaction. Now let me show you the interaction with the smart contract itself. So now, if we want to perform call operations, which is operations that don't require me to change state. Like if I try to get the name now, I'm not changing any state, but I'm not changing any state. The state is the way it is, right? Okay, there's this particular code here that sends ether, but you just when you get this code, you just look at it. But yeah, this sends ether. Data in this private key is not enough, so I don't want to waste it because I'll actually use it to call this update name. So just pardon me. You can check it out yourself because if I send now to reduce the amount of money I have on this address, and I don't know how to get another one right now on this call, or rather I wouldn't want to start getting another one. So yeah, but this operation here is for sending ether. So now for us to perform operations that change states, we need our private key. So you've seen the idea of provider. Now, this is what Ethers.js calls a signer. So this signer is more like an abstraction on top of your private key. So just like we can't use this URL just on its own. Like as this URL is like this now, you can't really use it on its own. You need to pass it into this place that makes it a provider that Ethers.js understand. The same way you can't just carry private key. But this thing now is just a big number. Here itself is a string, but private key number is just a very, very, very big number. But here is a string. So just using a string is nothing. This thing is just a string. But for it to make sense to Ethers.js, we need to wrap it around this Ethers wallet and passing the private key here. Now, what this does is that this passes, like this converts it to a signer. So a signer is an abstraction of an account. So a signer can perform any operation that you can perform. You understand? So this signer now is representing me, representing my address. So this private key, once I have this private key now, I can perform operations that change state. You understand? I can perform operations that change state. So now this place is where a handshake happens, more like a connection. So from the variable name, you see this is the signer, but this is a signer with provider. So I have a signer, I have a provider. I want to bring them together. This is what happened here. Understand? So this is a signer with provider. It's a signer, but I've connected it to the provider. So now it's now a signer with provider. So they kind of now this signer is now not just on its own, but now it has the ability to interact with the blockchain. Before it was just a signer, just have an account. But now that it's connected to a provider, it now has the ability to talk to the blockchain because of a provider already contains the details necessary to talk to the blockchain, right? So yeah, that's that on that. So now let me call the first operation, which is this. So let me so this is how I instantiate the contract. Now I pass in the contract address, I pass in the API that we talked about previously, then I pass in this signer with provider. This contract class can take in just a provider, or it can take in a signer, but in this case, it takes in a signer that's connected to a provider. So if I want to perform operations that don't require me to change state, I can just pass in a provider. Understand? Here, you will actually see the good documentation. I can pass in a provider here without actually, okay, let me actually pass in just a provider. So you see it. Because of the operation I want to perform is this name operation, and this name operation doesn't require me to change state. So if I come here now and do run, it should return the last name we use. I think gospel easy, yes. Gospel easy, right? It didn't throw any error. But let me actually try to use the same provider and perform and call an operation that changes states. So let me just change this to jelly that. So now when I perform this operation, you would find out that it will throw an error because just a provider is not enough to change state. Because for you to change state, you need to sign. And when if you need to sign transaction, you need a signer. So let me call this operation now and see the error to throw. So it's telling you that unsupported operation, sending a transaction requires a signer, right? You see it here. You see it here. So basically, if you want to send a transaction, so this thing is not a transaction, it's just a call request because you're not changing state. But when you need to change state, you need to pass in a private key. Sorry, a signer, which you can get from a private key. So if I change this back now to signer with provider, because also if I still come and pass in only signer here, it will not work because the contract needs to interact with the blockchain. So is it that I pass a provider for call operations, or I pass in a signer with provider for transactions that for operations that change state. So I'll come here and add I'll take this signer and bring it here. So this should work. So let's see, let's run this. Okay, let me clear this. So if I run this now, this will take a bit of time, but it should work. So this has not changed, but like this is just a transaction. It has started the adding process, but it does not mean that it has worked. So let's just give it a bit of time. Or okay, let me take the transaction hash and go and look for it on the blockchain so we can follow it up. Okay, I'm showing only one screen. You will not see it. So let's just wait a bit. Let's just wait a bit. Or let me just try my luck and see if it has worked already. Let me do this call again. Nice, it has worked, right? So the name is now Jelila instead of Godspower. You understand? So instead of Godspower. Now let me go and check my balance. You see that the balance has decreased. Let me check the balance again. I check the balance again. It has decreased, though it didn't show that much because it's not really an operation that collected a lot of, but this is not how it was before. So let me change the name again to, let me give it to, I've used, which person name should I use now? Let me look for the person's name I'll use. Let me use Chiamaka. I'll use, so when I call this, okay, let me remove this. So if I try to call this now, it's supposed to change to Chiamaka. So okay, so it has started the process of adding, but if you look at this thing, it shows 0 confirmations. You understand? That means it has not been confirmed. But let's just wait small. Let me go and try it now. Hopefully it has worked. So if I try it now and try to get the name, that's changed to Chiamaka, as you can see. So we've successfully walked through how to use Ethers.js to interact with the blockchain, right? Yeah, we've successfully done that. So I'll share this code with you guys as soon as I can. Immediately after the call, I'll share it with you guys. I'll add it to the folder and share it to you guys. So yeah, now let's go to doing the same thing, exactly the same thing. Okay, go ahead, ask.
Could you give us the permission to be able to fork your repository?
The repository is public. You can fork my repository.
All right, okay.
Yeah. So I would have said you should just come to Replit and check this out, but not everybody will know how to use Replit. So I'll just add it to the yeah, you guys can fork the the Web3 ladies court repository. Yeah, just go ahead and do that so that you can have it for yourself and keep updating it. So yeah, let me go and do this exactly the same thing I just did, but I want to do it with Web3.js. Now you probably see why I said I don't like Web3.js, but Let me stop sharing and share that particular screen. But so far, does this make sense? Okay. Okay, the link to the repo. Okay, please, can someone just do that, please? Please, someone should just like get the link of repo and share it on the chat. I'll try to share the Replit URL. Okay, let me just do it now. Let me just do it now. How do I get the link? Invite, no, generate a join link. Okay, invite friends to join. Okay, so yeah. Okay, thank you, Rita. So this is the link to the Replit for the one I just talked about. And let me do the same for the one I'm about to talk about. Generate. This is the one for the Web3.js that I'm about to use. So let me share my screen for Web3.js. Yeah. So the same idea, right? But different tool. The same goal, but different tools. The same thing. I have my RPC, I have my ABI, I have my contract address, I have my private key. Now, this is how I'm instantiating Web3.js. Now, this is how they pass in their own provider. So I do new Web3 providers, HTTP provider, and I pass in this URL, right? Similar idea. Okay, you see as I brought in this one. So this Web3 you're seeing here is this one now, like the same thing, right? So, sorry, the way I pass in the URL and make this Web3 native, this is it. So I'm kind of like the way it's done in Web3.js is that you need to instantiate it, and when you're instantiating it, you pass in a provider. You understand? But that one provider is different, signer is different. But this one, as you're instantiating, you need to pass in a provider. So yeah, let me do the same thing I did before. Now I want to get the block, right? You remember that we did it just now in Etas.js. So in Web3.js, this is how you get the block. So let me run this code. So this should, yes. Oh, it's still running. Okay. Okay, I don't know if you notice what happened. This is already running, like it's interacting with the same contract. So that's why it's returning Chiamaka that we added before. So yeah, so this is the block number. It has increased since the last time we checked. Normal transactions are adding per second. So yeah, this is the new block number. So this is how it's done in Web3.js, Web3.ether.get block, right? So this is how it's done. Yeah. So now I want to get my balance. The same thing I did before, right? But now the same thing I did before, and it's actually like, for instance, now the first can give you away. Then they still have tools for you to be able to convert it. Like you saw before, I used Ether.js to convert. Now I use Web3.js. So I just did Web3.utils. Then from way, I pass in what I want to convert. Then it gives us the new balance. So when I run this, you see it. So when I run this, you see my balance. They first showed me this long value that I don't understand. Now, when I converted it to Ether, it showed me the value that everybody understand 0.05. So yeah, that's it. So yeah, that's it. So this is for getting balance. The reason why I'm just walking through really quick is because I already showed you how this works in Ether.js. Now, this is the same operation I told you that I don't want to do because I don't want to waste Ether. But I think now you actually start seeing why I don't like Web3.js, because some things are unnecessarily complex. So now the same thing I did with 3 lines of code in Ether.js, I'm doing it with like, I don't know how many lines of code here. So I have to pass in this private key again on its own, blah, blah, blah. I'll first sign the transaction. Then I'll now send the signed transaction, that kind of thing. Okay, go ahead.
Okay, like this gas fee that is fixed here. Are you the one that calculated it yourself?
which one? Okay, that's not actually gas fee, that's the gas. So the amount of gas needed to send ether on the Ethereum blockchain is static. Is this how many? Is it 200? Is it 200,000? I think it's 20,000, the static gas. Well, even if I don't put it, they'll help me and calculate it themselves. It will be calculated automatically if I don't put it. But yeah, I think every transaction to send ether costs 20,000 gas. So this is not the price. Oh. Mind you, there's a difference between gas price and the gas itself. So gas is like fuel. Then gas price is the amount of how much you're selling fuel. That's the best way to see it. The gas is that, okay, I want to buy fuel. You want 100 liters of fuel or 10 liters of fuel. Yes, 10 liters of fuel. So then they'll not tell you that 1 liter is X amount of money. So that's how it costs. So they'll not tell you that, okay, you need 20,000 gas. You want to pay 20,000 gas, but then one gas is cost X amount of money. Then you do the calculation how much it will cost generally in the whole blockchain. So yeah, it's just similar. Gas and gas price very different. So yeah, and you also specify that if I don't specify it here, like I didn't specify it here, but it will be calculated for me. So there are even functions to estimate gas. Understand? So if you want to cut costs for yourself and your company, you can try to perform these operations beforehand and make sure that you are achieving like the goal of sending ether fast, and also sending it like in the right time. Sorry, sending it fast and with a cheap, because the higher the gas price, the faster it will be, but the higher amount of money to cost. You understand? So if you have high gas price, you're likely to process your transaction very quickly, but it means that it's more expensive, right? So you need to take note of those two things. So let me go and comment this out. I don't want to send it out. I don't really have enough. Like, see, it's showing 0.5 here. Yeah, so I don't want to send it out. But yeah, this is what you need to send it out. Or should I just let me just leave it? So far I just know that what it does. So let me comment this out again. So now this is the same operation we saw before, but now this is different. See their own. This is what they call contracts. They pass in the contract. Sorry, they just pass in the API and the contract address. Before we pass in API, contract address, and the signer. But we still have to pass this signer somewhere else. You understand? So now this is the name. So if I do name now, we should get the name said before, which is Chiamaka, yes, because we are actually interacting with the same contract. You understand? So this is the name. Then now let me see the next person's name I want to use. Let me remove this. So you also see again why I said I don't like Web3.js. Do you know that this particular part, I had to go and do research myself. It was not on documentation. I don't know why something as important as this will not be on documentation, but it is what it is. So which person name would I change it to now? Okay. Inyoma is the new name we set. So let's change the name to so this is a new name I will set now. So if we call this, we're going to change the name. So let's run this and wait. So similar to what we got before, the same transaction stuff. They told us it's not the same return value, but similar, right? Transaction, this is block number, the gas used. So I actually pass in this amount of gas, but what was used is this. So take note, if you pass in more, the remaining will be refunded to you. Understand? So if you bought 100 liters of fuel and you pour and you try to put inside your gen and only 10 enter, remaining is your own bar. That is the same thing that happened here. We actually say we we are willing to pay for this amount of gas, but this was used, so they'll return the remaining for us. That's how it works. So now, if I try to get the name now, it should show the new name. So yeah, let me remove this. Let me run this. Nice. So we have our new name here, right? We have our new name. So that's it basically. That's it basically. So we have 7 minutes more, so we can't talk about Merkle tree, but we'll talk about it next week. So at this point, does anyone have any question? Please go ahead and ask. So nobody has any question.
Please, can we have these links posted to the resources channel?
Okay. All right. I'll do that, or I'll just post the code on the repo, so you don't have to go to the link. I'll post it on the repo. I'll create a node module and put it inside.
Okay, thank you.
Yeah. Bakare, go ahead.
Yeah, okay, sorry. The Ether.js and Web3.js, is it what interacts with the front end?
Yes, exactly. So if you want to interact with the front end, you would write functions that will talk to these functions. Like you would just your functions will use Ether.js or Web3.js to return values from the blockchain for you.
So now
Just
can
like
I
you
do this
making
in
API
like
calls.
my React project?
Yes, exactly. Yes, you can use it on in your
Okay.
React project. It's not here. So I guess that'll be all. If in the absence of questions, um I'll I'll drop your assignments. I think today or tomorrow. I'll drop your assignment, and yeah, that's it basically. Thank you guys for coming today. We'll call it
Thank you. Bye.
a day. Have a good night.
Thank you.
Yeah, welcome.